In this problem, it says, based on a survey, 34% of likely voters would be willing to vote by internet instead of the in-person traditional method of voting. For each of the following, assume that 15 likely voters are randomly selected, and we're going to start with part A. It says, what is the probability that exactly 12 of those selected would do internet voting? So we're looking for probability of exactly 12 successes. And so in this one, we're going to use the Binomial PDF function because there's only one value here. So my number of trials is 15. Probability of an individual's success is 0.34, and there are 12 individuals. We're looking for the probability of getting exactly 12 who would do internet voting. And when I put that into my calculator, let me do it this way, because it's long, I'm going to get 3.12169 3124 E negative 4. So this is in scientific notation. That means I need to move my decimal point over 4 places. So this is going to turn out to be 0.00031 because they said to round to 5 places. So that's how I get that answer. Now, that was the probability of getting exactly 12 successes. So very small probability. In part B, it says of the 12 selected, if 12 of the selected voters would do internet voting, is 12 significantly high? So we want to know if the probability of 12 or more people voting on the internet, is that a significantly high number of voters? So what I'm calculating here is the probability of 12 or more successes. So that's different from 12, specifically 12. We want 12 or 13 or 14 or 15. And so because we're on the high end of the number line here, that's what would indicate that that was a significantly high number of successes. So now I want to calculate the probability of 12 or more successes. So this would be 12 to 15 successes. But when we're putting this in the calculator and using our Binomial CDF function, because now that's a range of values, we want to start at 0, or we need to start at 0. That's the way the calculator works. So the calculator could do the probability of 0 to 11 successes. So we're going to convert this, and I'm going to say it's the opposite. So we're going to do 1 minus the probability of 0 to 11 successes. So this is 1 minus Binomial CDF. And we started with 15 trials. And probability of an individual success is 0.34. And we want a maximum of 11 successes there. And I'm just going to erase this so we have room to fit this in. And this turns out to be not very much more than the probability of 12 successes by itself. So it's 0.00035. So since that value is very low, it's less than 5%, and that's our standard. If it's less than 5%, then we would say probability of getting 12 successes is significant, or the 12 would be a significantly high number of successes. So, because the probability is low. So that's what we get for that one. And then for part C, it's asking us for the probability that at least one of the selected likely voters would do internet voting. So I'm going to put that down here, part C. Probability of at least one. And we calculate the probability of at least one by taking 1 minus the probability of none at all. So this is going to be 1 minus the probability of 0 successes. And we can calculate this using really either the binom PDF or the binom CDF function would work. And we have 15 trials. Probability of an individual success is 0.34. And we want a maximum of 0 success, or we want 0 successes here. If we use CDF, it would be a maximum of 0. Either way, it winds up being equal. And this winds up being 0.998. And that's how you do that problem.